Hello, this is the first video for this week 5 for our applied machine learning class, and we're going to be talking about classification. So in this first video I want to look at a high level and what the process of classification is. Okay, so in MATLAB there is a book that has implemented some demos where we can see the process of classification. So what I'm going to do is I'm going to open it up in MATLAB and we'll have a look at it. What we're going to have is a new item. In this case it's a fruit that is being inputted. Then here you will see how the system kind of calculates the features, which in this case are the shape, the texture and the weight. Each of them will have a numerical value. Those features will be passed through a vector of weights here, these values here, that are randomly initialized, and together will go through an activation function. Depending on what the value of the activation function is, the result at the end, we will determine if it is, in this case, an apple or an orange. Let's see it in MATLAB. So if we go to MATLAB, we can type in NNDTOC. And this is our neural network design. That's the NND, and then table of contents. There are several demos. We're going to look at chapter 3, perceptron classification. This is our example. So basically what we have is we have decided that the values closer on this side of the cube are going to be oranges. The values on the other side of the cube are going to be apples. Obviously our new fruits that are coming in are not going to be in that point or that point. They're going to be in this three-dimensional space. But this plane here in the middle, cutting the cube in two, is deciding eventually with the activation function whether something is on the left, being an apple, or something is on the right, being an orange. Let's click go and get a new. So we see the full process. So we get a fruit. The system determines. Ooh, very noisy. And these three values that are here in our vector B, with the weights and the bias, get passed through the activation function. The result of the activation function here is 1. You see how the point here, this value here, is the result of the activation function. It's a bit difficult to see, but it's on the other side of the plane that divides the oranges and the apples. So the system decides that it's an apple. Okay. Let's now go back to our presentation. So we've seen how this system classifies fruits depending on shape, texture and weight. Those are the features. And then we have some randomly initialized weights, a bias, activation function, and then a threshold, which is this plane that decides whether something is on the orange side or on the apple side. Okay, another example would be a typical OCR, character recognition. We have the letter F, and each of those edges, corners of data are an input. So each of these inputs could have how many lines go into that point. So this one here is only 1, this one here is 3, 1, 2, 3, this one here is only 1, this one here is 2, this one here is only 1. That will give these values for the input layer. Then each connection from the input layer to the output is weighted. We have a weight for those connections, and depending on the combination of the input values and the weights, at the end you will have a higher value on this node, this node, this node, or that node, telling you what letter you were actually looking at, in this case F. The training phase is when you're adjusting those values of the weights to the known output. So for the training phase, you're going to give our system an input, let's say letter F, but you're also telling the system that we know it has to be F. So it recalculates all the values of the weights as you train it. And eventually when you give it a new unseen data, you give it this F, and with these particular values you will know what letter it is. Similar example would be these characters, where we can see different ways of writing the number 3, but they all share some common shape. You're missing a bit of the bottom, but you get the idea of the 3. And then our system should be able, after being trained with all sorts of different shapes of the number 3, it should be able to identify that anything with a similar shape to this is a 3. So these are the basis of classification. You have some features. That is really important to get appropriate features. Then they go in to an input layer. We're using an artificial neural network. There's a weighted connections between each of the neurons on the input layer and the output layer, as we saw on the previous slide here. Maybe it's easier to see. And the training phase means adjust all those weights, and then when you give it new unseen data, it goes through the weights and it activates the particular output. And in the previous example, either an apple or an orange. Okay, so in the next video we'll have a look in detail at artificial neural networks.